Good morning to those who are joining us. We'll get started in just maybe 1 or 2 minutes to let folks kind of trickle in here as the 8 o'clock hour on the Pacific kicks off. So hang tight for a minute or two, and we'll get started. All right, hello. I think 8:01 is good enough to get started. We have a good amount of people in the room, and we're all ready to go. So good morning, everyone. First off, and thanks for joining us for our final event of the Systems Engineering Forum for this fiscal year, I guess, for 2022. To start, as you saw, this meeting is being recorded, so please keep that in mind. I'm Alex Trujillo, and I'm serving as one of the co-chairs for the Systems Engineering Forum alongside Alex Chang. So that's us, and we got Lori Tracy helping us in the background to run things, so thank you, Lori. I will be helping to kind of facilitate this event and then kind of walk through slides and all that. So if you can see the welcome slide that's up right now, before I introduce our speakers, I'll do a bit of housekeeping. So as you know, the Systems Engineering Forum is hosted by the Aerospace Corporation and the Corporate Chief Engineer's Office. It focuses on applying innovative systems engineering principles across the space enterprise, contributing, hopefully, to mission success while advancing the state of the discipline. And it's applicable, as you are aware, to a wide range of audience members. So welcome. Once again, like I mentioned, the meeting is being recorded. Including all question and answers, and the chat as well will be saved. So chat or voice will be saved, and it will be posted on YouTube in a couple of weeks after this presentation, or after these presentations conclude. And you'll receive a link to all of that if you are a registered attendant of the meeting. So some housekeeping. So the presenters today kind of asked the audience members to use the chat box to ask questions and kind of, have a discussion, have a lively discussion even during the presentations, but keep it to the chat box, and do remember to keep yourselves muted. If you're asking maybe perhaps a more complex question, we'll try to get to you, have you speak at the end of each of the two presentations. So please do remain muted and use the chat box as you feel necessary. So if you're experiencing any technical issues while using Zoom, I think Alex Chang will post some troubleshooting there, but hopefully you're all able to hear us well. But with that, I think we can get started for today's event. So today's theme, as I'm sure you saw when you registered, is digital engineering standards, where we'll be exploring how standards can be developed and deployed in digital engineering efforts and in a digital engineering environment or ecosystem. So our presenters are, first we'll have Dr. Matthew Daskilewicz, who will be talking about establishing authoritative sources of truth. And secondly, we'll have Daniel Winton talking about different approaches for management of standards. So we have our first presenter here. We'll start off with a bio, and then we'll let him get going. So our first presenter is Dr. Matthew Daskilewicz. Matt is a senior engineering specialist in the Systems Engineering Department here at the Aerospace Corporation. In this role, he is a lead developer of the Portfolio Decision Support Tool, or PDST, and he contributes to several digital engineering initiatives around the corporation, including as a member of the Corporate Data Governance Strategy Team. He is also particularly interested in building interactive software for understanding and communicating changes and updates made to models and data as programs evolve, and solutions for making information accessible across tool boundaries. Matt holds a BS, an MS, and a PhD, all from Georgia Tech. Go Jackets. So with that, we'll begin our first presentation. You can take it away, Matt, if you want to share your screen here.
All right, thanks, Alex. Give me 1 second. Oh, apparently you have disabled screen sharing for me.
Lori, can you get him, let me see if we can make him 1 second.
Okay, we're good.
Can you try that now?
Yes. Okay, is that working?
Yes.
Okay, great. All right, thanks for the introduction, Alex. As Alex said, my presentation is titled Establishing Authoritative Sources of Truth, and I want to acknowledge my co-author on this, Alana Carnevale, who helped put this presentation together and did a lot of the background work on this. Okay, so I'm going to begin by just kind of talking about what is an authoritative source of truth, which I think is still a very open question, as well as kind of why do we care about authoritative sources of truth, and kind of where did this whole idea of an authoritative source of truth come from? So the term has been around for a while, but I think the sort of modern current push really started with this DE strategy document that was published in 2018. And it laid out 5 high-level goals for digital engineering. And one of those, number 2, was provide an enduring authoritative source of truth. And when we look at kind of the other goals, all 5 of them, and kind of the context of what they're talking about here, it sort of, in my opinion, positions digital engineering as sort of a successor or a continued evolution of model-based systems engineering. And when you look at them, you know, if you kind of just read through the goals there, say number 1, formalize the development, integration, and use of models to inform enterprise and program decision-making. It sounds a lot like something we would say about model-based systems engineering. But I think this number 2 does kind of stand out among them as being a little bit different and a little bit more kind of the most concrete of all of them. You know, so, but it does kind of leave open this question of, well, what is an enduring authoritative source of truth? So that's kind of what we're going to talk about here, and how we go about creating one. So there's several different definitions that I was able to find, and I'll go through a few of them here. I'm going to start with the one out of that document, that Department of Defense Digital Engineering Strategy document. And when they define authoritative source of truth, they don't really say what it is, they kind of say what it does. So they say it's going to capture the current state and the history of the technical baseline. It's going to serve as the central reference point for models and data across the life cycle. And then they continue that up, and here's kind of another quote that I think sounds very similar to something we would say about model-based systems engineering. That sort of, you know, once we have the authoritative source of truth, the primary means of communication moves away from static and disconnected artifacts and shifts the paradigm to models and data. So definitely a model-centric view, and they put this, you know, image there on the right, though I think it still doesn't do too much to really clarify exactly what they mean by authoritative source of truth, but they're showing this kind of network of models, you know, connected to each other, these arrows showing data, information passing between the models, but this central hub labeled authoritative source of truth with arrows going to and from it. But again, they're leaving it very open as to what exactly they mean by authoritative source of truth here. So another definition, you know, a few years later, we get the US Space Force vision for a digital service. And they have something a little bit more concrete here. They say the authoritative source of truth is the single definitive source of a given piece of information that all consumers of that information should reference. And they specifically call out kind of a reason for doing so as to mitigate the risk of relying on outdated, inconsistent, or inaccurate information. So, you know, again, just getting a little bit more specific here, where we're now kind of stating an explicit goal or something that the ASOT enables. And I should say I'll be using that acronym, initialism ASOT, for authoritative source of truth throughout this presentation. So, a main reason for wanting this is just the kind of keeping everyone on the same page, right? That if we have a single authoritative source of truth for information and everybody is referring to that single source, then we can mitigate some of the risk of people relying on different sources that might be inconsistent or outdated. Okay, another definition from OMG. Now this is just from the OMG wiki, so I suppose different people could edit this, and it's maybe admittedly not the most authoritative definition of authoritative source of truth. But they call it an entity such as a person, governing body, or system that applies expert judgment and rules to proclaim a digital artifact is valid. So this is a little bit different. And I feel like they're putting more of an emphasis on the ASOT being sort of a person, or a group of people who judge the information to be, authoritative, rather than say like a software system that is sort of holding the information. So this is kind of a split you see between some different definitions. Is the ASOT sort of a piece of software? Is it a model? Is it a group of people? In this presentation, I'm largely going to refer to the ASOT as if it's a piece of software, and I'll refer to the people responsible for it as the ASOT owners or the governance team. Okay, and finally, I wanted to call out this other one, this particular study from Adventium Labs, and I put a link there to it at the bottom. I wanted to reference this specifically because I think it's a really good study. If you're really interested in this idea of authoritative source of truth and want to see a very detailed study on it, this document linked at the bottom here is about 200 pages long. And they really conducted an in-depth study where they interviewed a lot of people and kind of collected all sorts of ideas as to what an ASOT is and the capabilities it should provide. So I think this is kind of a great place to go if you really want to kind of dig into some details. But they define the authoritative source of truth as a capability that gives definitive answers to queries about a collection of systems. So again, leaving it maybe a little ambiguous, what is the kind of physical instantiation of this? They describe it from a capability perspective. But I think that's a nice succinct definition. It doesn't try to say too much, but it's definitive answers, right? It's the place to go to get the most trusted answer to a particular question about a system or systems. Okay, so kind of some summation of these and kind of some conclusions from these. First off, I'm focusing on this term authoritative source of truth, but there's definitely some synonyms out there, or maybe you could debate whether these mean the same thing or not. So single source of truth, single version of truth, system of record, authoritative source of data. These are other phrases that we've seen out there. And kind of, again, we've seen different definitions as to ASOT. Each of these has different definitions as well. So, kind of when talking about authoritative sources of truth, maybe the first order of business is to make sure you're on the same page with whoever you're working with, that you're in agreement as to how exactly you're scoping that phrase. Are you talking about just a model? Are you talking about a model combined with interfaces that let people access the information it holds? Are you also bringing in, a governance board? Things like that. But some summaries here, kind of just based on the capabilities that we're saying the ASOT is supposed to provide, trying to draw some conclusions about it. First off, this idea, I'm going to say it must be digital, because kind of this whole idea, right? If we're thinking digital engineering as an evolution of model-based systems engineering, which itself I would say is, an evolution of document-based systems engineering, right? The whole idea is kind of becoming more and more digital. And by digital, I really mean this idea that the information is stored in a place that has an interface that allows people to query it and get succinct bits of information back. I can ask a very specific question to this API and get a very specific answer back. I can say, what is the date that a particular milestone is expected to occur? And I should just be able to get back an answer that is just that date, rather than having to dig through a document and try to find that date. Number two, must be accepted or agreed upon as the appropriate source. So some of those definitions, I think intentionally left this vague, right? And they talked about, expert judgment or preponderance of evidence that it's the right source. And I think they're, specifically avoiding more concrete terms like saying it must be verified or validated. Because I think there's a recognition that that's not always going to be the case, right? There can be information that isn't validated, and yet it can still have a most authoritative version. And so there can still be an ASOT for that, even without it being validated, if it is still the best version of that information you've got. Number three, should be quickly updated when the underlying facts change. So back to that Space Force strategy where they were calling out a main reason for having the ASOT is avoiding the risk of outdated information, right? Keeping everybody on the same page. So, if a new decision gets made and that implies that the ASOT needs to change to reflect that decision, that change should be happening very quickly. Because again, kind of one of the major points of it is to keep everybody using the most recent data. Number four, should address the whole picture of the data. So, a couple of the definitions mention, the life cycle, the word life cycle. This I think is a little bit more aspirational. Certainly you can have ASOTs that don't address the whole picture of the data, but you're going to get the most utility out of it when you do, right? The more of the life cycle you can be addressing authoritatively, the better off you're going to be. And finally, this last point, could be the primary source or could originate from other sources. So, I would argue that the ASOT does not necessarily need to be the original source. And part of this has to do with this idea that it must be digital, right? If the original source is not itself digital, but the ASOT needs to be digital, then there kind of still needs to be sort of that translation in there. But part of it is also sort of crossing organizational boundaries. And sort of my point here would be one organization's ASOT might be different from another organization's ASOT for the same information. Say I've got a customer and they're working with some data, they've got an ASOT for that data. They're sharing some of it with me, but they're not maybe giving me access to their ASOT for whatever reason. They're kind of choosing how they want to provide that information to me. Maybe now I become the ASOT for my organization for that information. So I'm definitely not the primary source, I'm a secondary source of that. But within my organization, maybe I am the ASOT. Okay, so that's kind of a little bit about what ASOTs are. Let's get back to this, the motivation for them and the capabilities they provide. So what is the role of them? So just a few very high level bullets here, and we'll be digging into more detail on these and others as we go along here. But first off, controls access to the information it contains. So this wasn't really covered in the definitions, but I think it's important to point out as kind of this part of this digital engineering vision is that if you've got sort of this central repository, say for information, a big part of governing that and securing it is obviously controlling who's allowed to see what, who's allowed to make changes to it, and kind of keeping track of that whole access side of things. So I'm not going to talk a whole lot about that in this presentation. That's definitely not something I have a lot of expertise on, but I think it's a very important thing to keep in mind. And also keep in mind in terms of the scoping, right? This idea that an ASOT is more than just a model. It's support systems around a model or support systems around the data set that sort of help your entire organization interface with it. Number two, this idea of keeping everyone on the same page, reducing errors. Talked about that a few times already. So won't say too much about it again right now. But this is kind of when we think authoritative source of truth, right? That's really, I think, the marquee capability that a lot of people associate with it. So number three gets into more, what are we doing with digital engineering and digital engineering workflows? So I'm saying an ASOT enables automated analysis workflows. And I'm calling that CI/CD style analysis. So CI/CD is an acronym from software development. It stands for continuous integration, continuous deployment. And it's the idea that you're trying to minimize kind of the cycle time between when somebody makes changes to some code, some software source code, and when that change makes it into the hands of the users. So kind of just, reducing that cycle time as much as possible. And it's the same idea here, with information in the ASOT, right? That as soon as the underlying information changes, if I've got, these digital automated workflows that can immediately, take that new information and start running analyses on it, that's, a great enabler for digital engineering. And then number 4, enabling recreating analyses done months or years ago. So the idea here is that the ASOT, while it provides, a snapshot of the current view of the truth, it should also be archiving all past states. And this is hard, right? This is version controlling not just the information, but, say the things down like the tool versions as well. So that, and this is kind of an example I put in here because we use this as sort of a thought experiment a lot when we're talking about setting up digital engineering workflows and ASOTs. And the kind of thought experiment is, I've got some analysis in mind. I'm trying to kind of establish ASOTs to support some analysis. If I do the analysis, I share the results with the customer. If they come back, a year from now and say, could you redo that analysis? How do we go about that, right? A year from now, we've probably forgotten a lot of the details. So, do we have enough of an enduring record of not just what the state of the information was a year ago, but, the versions of all the tools we used, just all of that, everything that goes into that analysis and producing the results. Are we able to kind of roll back the clock to exactly the state of things as they were? And again, this idea here, right? The ASOT is maybe more than just the information itself. It's the support systems around it. Okay, so these are some big goals, right? This is not going to be an easy thing to accomplish. So where do we even begin? Kind of little takeaway message here is, don't try to solve all of these problems or have a plan for all of these before you get going. Because I think the best way to sort of find problems and solve problems is to start doing it. And kind of towards the end of the presentation, I'll have sort of a little kind of how to get started checklist. But definitely, I think kind of as we go, don't think of all of this as like, oh, if I can't solve all of this up front, I'm not going to get anywhere. I think the idea is, start small and grow from there. Okay, so I'm going to kind of boil all of that talk about background on what ASOTs are into sort of 2 main topic areas here on establishing ASOTs. And I'm calling those governance and utility. So the governance side is, kind of how do we use ASOTs? It's sort of the how side of things. The utility side is more like the why. It's, what are the capabilities it's providing and how is it actually helping me do my job better and why should we bother with all of this? So, kind of an early question you want to ask in governance is sort of what should be considered an ASOT? When you look at your organization and, however widely you want to scope that, your department or your immediate coworkers or say your entire company, what do you want to kind of draw the line and say, this is what we're going to consider to be an ASOT. These are the standards it should meet, things like that. An important point to keep in mind here, right? Again, this idea, the ASOT is more than just the model, and it's more than just the best model. It's got to include some support systems around that, right? And part of the reason it has to include the support systems is that, if you're going to declare something to be an ASOT, you're sort of making a promise to people, that this is going to be maintained well, right? This is going to be kept up to date. We're going to take this model very seriously. So, part of establishing the ASOT is kind of making sure you've got people who are willing to dedicate themselves to that and making sure you have resources to support those people. So, it's a lot of work to establish an ASOT, and it's even more work to maintain it. So, some things to think about before you begin saying a particular model is going to become an ASOT for a particular piece of information. Is it ready for prime time? Just kind of to put it casually. is the model correct in its current state? Is it complete? Does it have documentation? How much demand is there for the information it contains, I think, is an interesting one. There's maybe the right answer is enough demand, but not too much demand, right? If you're kind of going down this path and saying, like, we want to start experimenting with ASOTs, you might want to start with something that, say, a handful, a few dozen people rely on, right? Enough people that you can kind of tell that you're doing it well, but not trying to kind of upend the management of a data set that your entire corporation relies on. Do support systems needed to extract information already exist? So this is something I'll hit on a lot in the second half of this presentation here. I've kind of avoided up to this point, and I'm going to try to avoid as much as possible saying something concrete like, the ASOT is probably going to be, a UAF model, something like that. Maybe it will be, maybe it won't be, and it's going to depend on, the type of information you're talking about, the type of work you do, of course. But let's suppose it is something like an MBSE model. That's not the kind of model that everyone in your organization is going to know how to work with, right? So, and kind of regardless of what it is, whether it's MBSE model or just, a very elaborate Excel spreadsheet, say, there's going to be people who understand how to work with it and people who don't understand how to work with it. But as the ASOT, you want to make the information available to everyone. So you're almost certainly going to need some way of getting information out of it so that non-experts are still able to query it and access the information. So that's why I kind of call out here in this third bullet, support systems for extracting information. So, do they already exist, right? Depending on, if we're saying the ASOT, kind of the core of the ASOT is a model that lives in a particular piece of software, does that software already provide nice APIs that make it easy to query things? Or is that something you're going to have to build? And finally, are the owners on board, right? Are you trying to kind of force this ASOT label onto someone? Or is this something that they're willing to take on? Okay, next idea here, sort of what standards are we going to hold the ASOTs to? So I'm going to, not try to kind of tell you what standards you should hold your ASOTs to, rather just kind of pose some questions here. But at the end of this presentation, we probably won't have time to actually go through it here, but in the slides, there's kind of a somewhat lengthy questionnaire that you can kind of go through that sort of addresses some of these ideas of standards that you should maybe be holding ASOTs to. So again, this idea that when you declare something to be an ASOT, you're partly making a promise, right? It's like, why bother, right? Why establish that something is or is not an ASOT? That when you establish that it is, you're making a promise to people that it's going to be upheld, standards of quality, security, usability, that sort of thing. So I would recommend, establish this idea of a governance board at your organization to decide what those standards are going to be. And, actually have this idea of something being certified as an ASOT. Don't just kind of make it casual. Make it something a little bit more formal and have written down somewhere that, if we say something is the ASOT, we are striving to promise the following things to you. In addition to those questions in the appendix of these slides, again, that Adventium Lab study, which I've got a same study, but another link to on this slide. And I called out kind of a couple bullets here, but they've got dozens and dozens of these, basically requirements for an ASOT. So, if you want that level of detail, definitely recommend checking out that study. And it's great food for thought of, when you kind of read through here. The ASOT supports all stakeholders by enforcing constraints. It's like, okay, well, do we want to enforce that for our ASOT or not? Do we want to say, the ASOT is responsible for enforcing constraints? So definitely check that out. They go into a lot of detail. And again, kind of this idea of separating maybe the idea of an ASOT owner from the ASOT itself. What are the responsibilities for the owner? It's something you want to make clear to them up front, right? When you ask someone to manage an ASOT, make sure you're spelling out what those responsibilities are going to be. again, this questionnaire at the end, I'm calling it here a self-assessment for potential ASOT owners. The idea here being kind of, give them some questions to kind of think about. Are you ready for this? Do you have the support systems you need already? Do you have the funding to pull this off? Do you have an interest in getting this information in front of more people? Things like that. And then finally, provide compelling reasons for them to want to get on board, right? It's nobody ever wants somebody to just show up and say, hey, we've got a whole bunch of new responsibilities for you to do in addition to the job you're currently doing. There needs to be some incentive, right? There needs to be some benefits spelled out of, look, if we can do this, this is how it's going to make all of us be able to work more efficiently. Okay, pivoting over to the utility side. So again, this idea of utility, what are the ASOTs doing to help us actually do our jobs better? And I'll kind of argue up front, right, that the whole point of the ASOT is to help people do their jobs better. That, if you're just kind of doing it to put some regulations in place, it's just going to be more work. People aren't going to see value, and they're not going to want to be part of it. So, think about that. How is it going to add value? And here's just kind of some food for thought here. Again, this idea of supporting work of people with different technical backgrounds, right? That the ASOT might, have at its core a model that relatively few people understand how to build or understand how to use the software that interacts directly with that model. But you want the information content there to be widely available. So, how do you ensure that that's going to be possible? The second bullet, this idea of performing what-if analyses. So, back to those definitions at the beginning, we talked about the ASOT, capturing the past and present values of the technical baseline. But a lot of what we, need to do in day-to-day work is this idea of a what-if analysis. We need to make some changes, right? I need to say, well, what if we miss that deadline, right? Or, what if this particular component comes out not as reliable as we thought it was going to be? So, does the ASOT enable that, right? And there's kind of the idea here, do you have the ability to let people make changes to it without declaring those changes to be authoritative? Is there, coming from kind of the software engineering world, we would think of this as like branching. I'm going to branch off the model and I'm going to make some changes to it and use that without, contaminating the original authoritative source with my changes. Third one down, again, this idea of retrieving past versions. How easy is it to do that? How easy is it to go back in time and say, ooh, how did I run that analysis 6 months ago? Fourth one down, this is kind of a new idea, something we haven't talked about yet. But a system is in place to alert users when the ASOT is updated. So, Alex said when he was given my bio, I'm particularly interested in, communicating changes to information. So I think this is a pretty interesting way you could be using ASOTs, right? Often what's interesting to people is not the fact that the ASOT exists, or even necessarily, all the baseline information it contains, but how it's changing and why it's changing. If month to month, some milestones have shifted, right? Some things have gotten delayed. That in itself might be something people want to know about, and they want to be alerted to that fact without having to sort of dig through the entire model and check what has changed, right? They want some sort of notifications, right? So how can we do that sort of thing? And finally, impossible to accidentally break it. So again, this kind of ties back to that what-if analysis, just making sure that you've got a system in place that makes it very clear to people when they are changing the sort of underlying authoritative model versus when they are simply, branching off or doing a what-if analysis, something like that. Okay, so I'm going to just make a bold statement here. Utility requires standardization. The topic of this talk is nominally standards. I'm not really going to get into any details about specific standards here. But just this idea of ASOTs and their role in digital engineering, kind of everything I've been saying so far, it all boils down to the benefits we're getting out of the ASOTs involve information exchange. The ASOT is the source of information. I'm trying to take information out of it for some purpose. I almost certainly want that process of taking information out to be automated, right? This whole idea of digital workflows and the CI/CD idea, right? I want to be able to build automated processes that are pulling the information out and doing something with it. In order to have that sort of automated information exchange, there needs to be an agreement between the ASOT, the source of the information, and say, we'll call it the analysis tool, the destination of the information. There needs to be some agreement between them on how this information is formatted, how it's going to be structured, things like that, so that we are able to build these automated tool chains. We don't want to be in a situation where, I need a human in the loop there, that I get my notification in the morning, oh, the ASOT has new data, and that means I need to come in and sit down and manually pull out that data, and then, I'm going to drop it into Excel and do a bunch of transformations on it to get it in the form I need it. We want kind of agreed upon interfaces between them. So that right there is kind of the idea behind standardization. Now, how hard is it going to be to do this? Well, that obviously depends on a lot of factors. It's going to depend on, again, what is the original source of your ASOT, right? Was it kind of already built with some standards in mind, or was it not? And similarly, what is the nature of the analysis tools you're using? Were they built with some standards in mind or not? Even if they were all built with standards in mind, were they built with the same standards in mind, right? There's unfortunately plenty of standards to choose from. So this is potentially a rather large hurdle to, not necessarily to building the ASOT itself, but to getting the utility out of it, right? But the sooner you start thinking about that, the easier time you're going to have, right? If you kind of establish your ASOT without first thinking, is this providing standard interfaces that I'm going to need downstream to do something useful with this? Then you might end up going down, the wrong path with your ASOT. Okay, so again, this idea of making information accessible, I'll say, just publishing an MBSE model in a shared folder is not enough, right? That's not making information accessible. Because again, there's going to be a lot of people who need to use it who don't understand what an MBSE model is, right? They don't understand how to work with that. And even if you say, well, Cameo, say, provides plenty of APIs to get information out of it. Well, if people don't know how to use that, then the ASOT is useless to them, right? So sort of building, documenting these APIs is definitely part of what I would consider establishing the ASOT. And again, just kind of the sooner you start thinking about that, the better off you'll be. Okay, I want to go a little bit deeper here into kind of a specific example here of sort of extracting or abstracting, maybe I should say, abstracting the information content of a model. And I'm going to use this example from this idea of the semantic web, which is an idea, from the internet, or kind of how to make the internet work that started, I don't know, 10, 15 years ago at this point. And it's kind of an idea for making it easy for different websites, say, to exchange data with one another in machine readable ways. So some key ideas, we'll talk about more about some of these on the next couple slides. First off, this idea of a knowledge graph. And this is kind of just the idea that you can represent information as a graph. I mean graph in sort of the graph theory sense here, where we've got different objects, which are things. They're going to be the nodes in our graph. And then we've got what they call predicates or relationships that say how those things relate to each other. And we can abstract different types of model information into this idea of a knowledge graph without needing to rely on a more specific level of detail, like saying this is a UAF model or this is a SysML model. Next concept is this idea of an ontology. And this is now adding some specificity to what are the types of objects we're going to allow in this knowledge graph, and what are the types of relationships we're going to allow between those objects. And then the final two, I'm not going to touch on too much in this talk here. But the third one, using URLs as a unique identifier. And regardless of whether you're using URLs or not, again, the use of URLs is definitely tied to this idea of the semantic web. But the more important idea is just having a unique identifier for a piece of information. The nice thing about URLs is they're kind of hierarchical. And you could imagine sort of just having a website interface where I've got a URL that's like myasot.org, and then I can just sort of have / scheduled information / milestones / initial delivery to customer / date. And if I go to that URL, it just displays the date that initial delivery to the customer happens. That's kind of just a very simple made up example, but the idea being a URL, you can kind of build a query right into it. And so the query can point you to a particular piece of information. And the URL itself serves as both, the location of that information and the identifier of that information. And final point here, using RDF as a standard for communicating the content of a knowledge graph. So if you're familiar with OSLC, you'll see some overlap between OSLC and these. And I'm not really going to talk about OSLC, but it's definitely a strong contender for a good standard to use for building ASOTs or building systems using ASOTs. And kind of the whole idea of it, well, I shouldn't say the whole idea, but a main idea of OSLC is applying these semantic web ideas to systems engineering information exchange. Okay, so I want to talk a little bit more now about this idea of kind of the knowledge graph and the ontologies. And the point of all this is kind of, again, sort of abstracting away from tools, right? Don't get hung up too soon on saying, oh, I've got this model in a particular piece of software, therefore, that's what my ASOT is. Even if that's how you're going to end up, I think a lot can be learned by just sort of abstracting back and taking this kind of higher level view of, let's just think about the information contained in that model. So again, this knowledge graph is just a way of sort of abstracting the information away from the specifics of how it is implemented. So again, a knowledge graph consists of objects connected by links or relationships or predicates. Each link or predicate is going to basically have a subject and an object. It's going to say one thing relates to a second thing in a particular way. Each object, each link can have properties that define it. So it can have some defining information. And that's kind of what I would consider the real knowledge content of the graph. That's sort of the real, what we would consider kind of the core information. But you can also have metadata associated with them, which I'm calling non-knowledge data. But the metadata might be things like, when was this information last changed and who last changed it? It could also be things like a reference. It could just be, here's where this information came from. And I'll say here, knowledge graphs are most useful when they have small nodes and many links. So by small nodes, I mean not too many properties associated with each node. And this is, I'm kind of taking an idea here from object-oriented programming. There's a concept called the single responsibility principle, which says each class, when you're doing object-oriented programming, each class should only do one thing, should have a single responsibility. So, as you're kind of thinking about a knowledge graph and kind of thinking how you're going to subdivide information into objects, try to keep the objects as simple as possible. So like a simple example, if we had a satellite object, I don't want to put in that satellite object, absolutely everything I know about the satellite. Instead, I would probably make that satellite object have links to other objects. For example, it would have a link to an orbit object, and the orbit object would have information about its orbit. And maybe it would have a link to different payload objects, and each of those have information about the payloads. Rather than just have, I've got this kind of monolithic satellite object and it's got 500 properties that just directly describe everything about it. And why that generally makes things easier downstream is, when I've got some analysis now that just wants orbits, if I've already got those kind of, encapsulated in their own objects, it's a lot easier to pull them out than saying like, oh, if I want to make an orbit object, I got to go read through my satellites and kind of construct it on the fly. So generally kind of having tinier building blocks makes it easier to compose the information you need rather than having big building blocks and trying to break down into pieces of information. Okay, and I put this postulate here, which you're free to argue with, but I would say any model can be represented as a knowledge graph. Okay, I don't want to get into too much detail here, but this is kind of just a simple little meta model here, kind of saying like, what does one of these classes look like? What are the objects that make up my knowledge graph look like? So, here on the left, we kind of have the idea of an object, and the object, so kind of the distinction, the object is sort of a specific instantiation of something versus the class is, kind of the general category of it. So like a class would be satellite, and then I would have a specific satellite is an object. So, a specific one, an object is defined by what class it is. Again, a unique identifier, right? This idea of having a unique identifier, which lets you, within an entire knowledge graph, pick out something specific and communicate that specific thing to somebody else or, to another analysis and be sure you're talking about the same thing. And then we have these properties, or here I'm calling them attributes. So I'm kind of dividing them into a few separate categories here. I'm saying required, optional, and custom. Required would be kind of the core definition. If I haven't defined these things, then I don't say have a valid model. It's considered incomplete. Optional would be sort of, these are still standardized. I still know that they're, going to exist, but I don't necessarily need them to say my model is complete. And then a third category, custom, which would just sort of be, non-standard basically. But, for a particular purpose or in a particular model, some additional information was added for some reason that sort of goes beyond the standard ontology. Okay, and then within each one of those attributes, so what defines an attribute? Its name, what sort of data it is meant to hold. There's sort of that dimensionality there. Is it a scalar? Is it a list? Is it something else? The value of that particular attribute, and then the metadata that goes with it. So again, classification level, references, last changed on date, things like that. So, that's kind of just a very high level abstract look at, sort of how you could set up a very general class structure for passing information around. And if you kind of think about the structure and you think about some common file formats for passing information like JSON or XML or RDF, you can kind of see how those would all support this type of model, right? It's not yet saying what the classes are or what their attributes are. It's just kind of saying, this is sort of just a way of structuring information that given a particular attribute value here, I can kind of trace it up and say, oh, okay, what class did that belong to and what specific object did it belong to and what knowledge graph does that belong to? And then once you start bringing in the links, you can start saying how these things relate to each other. So once we've got that sort of general model, then the next part is bringing in this idea of an ontology. And I think this is a very, very important part of building digital engineering workflows, is this idea of ontologies. And the idea here is that the ontology now adds a layer of specificity to what we just had on the previous slide, which just said, class, attribute. Here we're now going to say, what are the classes and what attributes do they have and what relationships can I build between them, and down to the level of like, oh, what units am I going to represent things in, things like that. So there's an example picture here that I took out of the W3C documentation, and you can see there that the URL there references RDF11 primer. So again, kind of this idea of semantic web, RDF, very closely related, and OSLC is also based on RDF. So I'm not getting into too much detail here about kind of exactly how to apply this in a systems engineering context, but it's definitely something people are working on. So I pulled this picture out because it shows kind of this interface between two knowledge graphs. And on the left, we've got, in blue here, this knowledge graph, which is presumably out of like a social network, defining this person, Bob, and, talking about who his friends are and what his interests are, what his birthday is. And we called out that one of his interests is the Mona Lisa, apparently. Very specific interest, but okay. And on the right here, we have a different knowledge graph, which is, the URL there kind of shows it came out of Wikidata. And so this knowledge graph is about art, and it's kind of tracking information about artwork. So I've got two different knowledge graphs, and the point here is that, can they communicate with each other? They can if they both understand what the other one means when they reference the Mona Lisa. And so this gets back to that idea of universal unique identifiers, right? That if, say, the phrase the Mona Lisa is itself universal enough that two different ontologies can recognize it as meaning the same thing, two different knowledge graphs recognize that as being the unique identifier, then that's great, they can talk to each other. But suppose they don't, right? Suppose in the social network ontology, it's just referenced as the Mona Lisa, but there in the ontology on the right, it's actually up there in the URL, it's actually referenced as Q12418. So, if there's nothing there that can make that connection between them, which I'm calling kind of the boundary condition here, that can kind of say, oh, when social network says the Mona Lisa, it means what Wikidata says, it means the same thing as what Wikidata means when it says Q12418. So there's kind of a lot to unpack here, but in the interest of keeping it quick, this is kind of the idea of standards, right? If these two knowledge graphs had agreed on an ontology to begin with, I wouldn't have this boundary condition problem between them. Now, as it is, it probably didn't make sense for them to agree on an ontology because one is about art and one is about social connections, right? There's really not too much overlap between them. But I do still want them to talk to each other. And so I need something in there to do it. I need some interfacing code or knowledge or something that says, how do these things go together? So in this case, it can basically be a mapping that says, oh, for this art ontology, I'm going to take all these little serial numbers here, this Q12418, and I'm just going to map that to the title of the artwork. And then, in kind of a more casual context where people are just referring to these by name, that's probably enough to make the connection. That, okay, maybe some people would spell it wrong and I've still got some problems there. But, that'll help me make a lot of connections anyway. Okay, so this is kind of the value of ontologies and why it's important to, kind of agree on ontologies that you want to use and try to get widespread agreement on them. Because kind of the fewer you have, the better. But there's definitely also kind of contrasted with that. It's not like you're going to have one ontology that describes the entire universe. The power of ontologies is to be tailored to a particular subject area. But, kind of within your organization, if you can say all agree that, when I'm describing a satellite payload and it's some sort of sensor, we're going to standardize the way we talk about that. These are kind of the names we're going to use for particular attributes. These are how we're going to represent numerical values. If something is going to be represented as an array, here's how we're going to represent it. Because if you can all agree on that, it makes it so much easier then to build tool chains that connect to each other automatically. Okay, I think I covered everything on this slide, so let me just hop on. I put a couple examples in here. I won't really go through them. But on the left are Wikipedia articles, and on the right are Wikidata articles. So Wikidata, if you're not familiar with it, it is a knowledge graph, and it's kind of the knowledge graph version of Wikipedia. Now, it does not contain nearly as much information, but it's a great kind of just learning tool to sort of get the idea behind these knowledge graphs and ontologies. And so I've kind of got the equivalent here. So like that first article, Apollo 11 on the left, that's its Wikidata article on the right. And you can kind of click through and compare the two of them. And you can kind of think about this idea of, sort of document-based systems engineering on the left versus sort of a more digital view of it on the right. Here I can just directly query for a specific bit of information and access it that way. And you can think about how this format makes it a lot easier to run queries. Where here I've got, say, Apollo 11 is an instance of human spaceflight. I can just run a query on this entire database and say, give me all the instances of human spaceflight, right? That's a little bit harder to do with something like Wikipedia, right? It depends on kind of looking for certain keywords, right? And does that human spaceflight keyword appear in there? But here, they're all going to be tagged as human spaceflight because that's part of the ontology. And here, it kind of enforces, I could click on human spaceflight here, and it'll kind of pull up a strict definition. Something should be tagged as human spaceflight if the following are true. Okay, just about out of time here, so I just want to quickly go through this sort of checklist for getting started with ASOTs. So kind of just 9 high-level bullets to keep in mind and kind of how to get yourself started. First off, store information in documented, well-structured formats that don't often change. So this is pulling in some of that notion of ontologies and common interfaces between different pieces of software. Well-structured, don't often change. Not going to say they can never change, but obviously every time you change your format, you cause a lot of headaches for people downstream that are using that information. Make sure it's documented, right? There should be no ambiguity as to how the information is supposed to be interpreted. Number 2, give objects permanent, globally unique identifiers when possible, as soon as possible. Again, this idea of if I'm trying to communicate information between 2 different ASOTs now, or maybe they're not ASOTs, maybe one's an ASOT and one's not. If I have this unique identifier that they both agree on, that makes it so much easier. Versus if they're kind of, I'm just referring to it by its kind of common name, say. And this is a big problem with like research projects, say. It starts out with one name, and then as it kind of goes through the years, it gets a little bit more refined, and maybe the name changes, and then it's like, oh, remember that thing we used to call it A, now we call it B. If they had a unique identifier that isn't really tied to the name, it's kind of just like a serial number. It's not necessarily human meaningful, but it's something that computers can rely on, that when I see this number, I know exactly what I'm talking about. Okay, number 3, use widely agreed upon standards, ontologies, schemas, and units of measurements as much as possible. We just hit on this idea, so I won't hit it again. Number 4, track data changes using discrete numbered versions. Didn't talk too much about this, but the idea is, for this idea, if I need to roll back to a particular state of the data, it's good if I have sort of a reference number or name for that state, rather than it's just like people come in and every day they're changing a number here or there, and I just kind of have this continuum of changes. That makes it a little bit harder to really track, to lay down a baseline and say, this is a particular state I want to be able to roll back to. So even if people are making changes, one at a time, say, you should still sort of have sort of named releases, sort of at the end of every month, say, we're going to have kind of a milestone release. Number 5, including a changelog explaining why the changes occurred. So this is bringing in that idea of metadata again, right? That often when things are changing, what's interesting is not necessarily, the change itself even, but why it changed and what the implications of that might be. And sort of the why it changed might be more of a clue to your users that they need to take some action. Number 6, separating authoritative from non-authoritative data. So try to have bounds on your ASOT and try to have kind of a clean line of what is part of the ASOT and what is not. And again, especially when you're getting started, there's going to be a lot of reliance on non-authoritative data. And by non-authoritative, I kind of mean not certified as an ASOT. It's not, the whole idea of ASOTs is not to say I should never use non-authoritative data, but it's that I get the most value when I am using authoritative data. So try to have a clear line between those 2. Okay, and the third are kind of really getting started tips here. Again, this idea of start small, establish component models before trying a composite model. So, what do I mean by those? Component, just, something small. Start with, the individual building blocks. Get some building blocks right before you try to put them all together and have, here's our view of the entire enterprise as an authoritative model. Number 8, don't insist on getting everything right the first time. I hit this at the beginning, but just this idea that you're going to learn so much as you go and as you start doing it. And really, I guess number 9 is pretty redundant with that, right? Start as soon as possible. Start local, look at just kind of your job and what you work with every day and what you can do with that. Okay, we're right at 9 o'clock, and I definitely don't want to take time away from Daniel. So I'm going to stop there. I just had 2 more slides here, but I think we'll make these slides available, and you can kind of click through these as well. So think about making it archival. This is that whole version control idea. And then I just put a couple bullets here about this idea of communicating changes, again, which I think is a particularly interesting topic that you can do. Again, this idea, it's not just necessarily the ASOT that's interesting, but it's how and why it's changing that are going to be interesting to a lot of people as well.
My presentation is much less shorter than yours, so I think that you can continue for a few more minutes.
Okay, well, let me just flip through these real quick, just so for like the YouTube video, we've got kind of a record of these being in here. So this appendix, questionnaire for potential ASOTs. So I won't read through all of these questions, but I'll just kind of flip through so that we kind of get them captured here. But these were just kind of some questions that I came up with that cover, potential ASOT owners might want to think about this, governance boards might want to think about this, but it's really getting at, I've got a model or a data set in mind. Should we consider it to be an ASOT or not? So kind of first big group of questions here, just what is it? Simple stuff like what is the name of the model? But part of this is covering sort of the scope of the model, the information it contains. And the reason we want to know this is because we want to know, are there other models that are also maybe competing for the title of ASOT, And, often you're probably in situations where in a large organization, 2 people are kind of tracking the same information and they don't even realize it, right? They're building very similar models and they don't even realize it. So this is kind of just, high-level survey of, what is this model you're working with? And can we use this to identify where there might be overlap or, potential overlap with other models? A little bit here about, again, I tried to avoid in this presentation talking about specific software, but in real life, when you kind of sit down to do this, the specifics are going to matter. So, knowing what software it was built in is definitely relevant. And again, this idea of standards or ontologies, is it built on particular ones? What are they? Okay, where does it come from? Where did you get the data from? Is this something that you're kind of directly getting out of another authoritative source? Is this something that's being calculated? Is it being measured? Are there subject matter experts who are, making it up as they go? Things like that. And kind of based on all of that, making some judgment call, is the quality sufficient? Is it timely enough? Is it easy to work with? Things like that. How is it currently being used? Who are your current users? But also kind of who can you imagine future users being? What are they using it for? Are your users internal or external? Are they involved in the generation or management of it? Scope and completeness. So, this is now getting to the question of, is this authoritative enough? So kind of just, ask yourself some questions here. Think about quality, completeness, maturity. And, back to that question I asked at the beginning, is this ready for prime time? And accessing the information. Again, this idea, the model itself is almost certainly going to need support systems around it that help non-experts access this information. So, do you already have APIs for that kind of thing? Are you using standardized formats for getting information out of it? Is there a query capability built in? Are there graphical user interfaces? All of that sort of thing. This idea of related models or related ASOTs, this gets that idea of component versus composite models. Is this kind of a standalone thing, or is it most often used in conjunction with other models or other data sets? And if so, kind of how do they relate to each other? Should those also be considered candidate ASOTs? The idea of management and governance, again, very important. Who are the people who are going to be responsible for this? Do you already have processes in place for governing this, or are new processes going to need to be implemented? Another whole set of questions related to that. Here, kind of this idea, some things to keep in mind when you're assessing whether the processes are sufficient. Are they efficient? Are they scalable? Are they secure? Are they user-friendly? Does documentation exist? A big one. Often we kind of have, a model and it's only got a handful of users and they all understand it. And a lot of there's kind of, tribal knowledge that's just passed between those users. But is that written down somewhere? Is that something that new users are going to be able to pick up? Access control, again, I didn't talk too much about that today, but depending on the type of ASOT you're dealing with, you're definitely going to need to think about how can you kind of make that information more widely available while still making sure it is only available to people who should have access to it. Okay, and then final slide here, just as food for thought. This is kind of just the blunt questions. Do you think this should be the ASOT? Just kind of give yourself a fair assessment here. Do you think more people would use it if they knew it existed? And this is kind of getting at, like, is there really incentive to make this an ASOT? Is it kind of like, it's already, we've got our 3 users of this model, but you know what? They're the only 3 users that are really interested in this. And there's not a whole lot of incentive to be really formalizing this and making it standardized and making it widely accessible. More often though, I think the answer to this question is going to be yes. It's like, yeah, this really, we put a lot of work into this. And if people were able to access this, they would. And then finally, do you have the resources, right? Always the question. Like I said at the beginning, nobody wants to just say, oh, I've already got my job and now you're giving me all these additional responsibilities. So, have a serious talk about what resources are going to be necessary to pull off that governance in the way it really needs to be done. All right, that's all I've got. Thank you all for listening today. Let me hand it back to Alex, and I'll keep an eye on the chat for answering any questions.
Great, thanks so much. Some great information there, and I think it'll be a useful reference for people in the future that are trying to build their own ASOT. So thanks for that. I will share my screen real quick here so we can introduce our second speaker here. Yeah, all right, here we go for number 2. So our second presenter is Daniel Winton. Mr. Winton is a senior project engineer at the Aerospace Corporation with 32 years of industry experience. As a practicing digital engineer, he applies expertise in model-based systems engineering, simulation, systems engineering, and systems architecting, as well as acquisition, risk, requirements, cost, scheduling, software, systems integration, and databases to solving hard and sometimes not well-defined problems. This is all part of digital engineering, as Mr. Winton states. He holds 2 master's degrees from the University of Southern California, one in systems architecting and engineering, and another in systems management. So with that, we'll begin our second presentation. So if you want to share the screen, Daniel, you can go for it. And while you're doing that, I'll say again, please keep your eye on the chat box. And to Matthew, I know that there are a lot of questions for you, so if you can tackle those in the chat box, thanks.
Okay, in theory, I should be sharing my screen. I'm assuming that is the case.
Yes, but you're sharing in kind of your email section there. So
great, that's exactly what I was expecting. Excellent, thank you very much. Now clicking on my presentation, there we go. Okay, yep. Managing standards in a digital engineering environment. And what I want to talk to you about is not just standards, but how they relate to the rest of the digital engineering environment as well, because standards just by themselves are just documents, but you really want to have those standards related to requirements and risk and design and test and so on And so we're going to talk a little bit about that. But before we do, I want to start with me. I am Daniel Winton, and on my door, I have a picture of Lucy with her sign up here. And instead of it saying psychiatry, I changed it so it says digital engineering help 5 cents. So you all owe me 5 cents. So everybody in here, send me 5 cents. So as I was in my office, one of my friends walked by and said, "Gee, I guess that makes you Dr. Digital." And I said, yeah, well, I may never have a PhD because my wife won't let me, but I can be a superhero. So I am now Dr. Digital. And there is, of course, my logo, and Dr. Digital is, of course, in the house. So we're going to have a conversation about digital engineering using common information infrastructure. I'm going to start from there because we'll tie it back to standards, but we really need to understand the idea of a common information infrastructure, because that is how we are storing and working with the standards and all of the other parts of the digital engineering environment that is related to it. So let's talk for a minute about the common information infrastructure. What is that, you might ask? Well, it's been around for a long time, but it was never given a name until I named it earlier this year. And so I now have coined this phrase called the common information infrastructure. So I own the name. I don't own the systems model that underlies it, but CII is my name. So therefore, I can use it, and so can you. So the CII, that is my definition. And what is the CII? Well, first, it represents the system's acquisition, architecture, and design in a single cohesive model. And how does it do that, you might ask? Well, it has a common information infrastructure that includes a common syntax and semantics, which applies across all of the model elements. And it has, because of that, an instantaneous update across infrastructure with simultaneous verification capability. I love all those big words, but basically what it means is you change the information in one place and it updates across the modeling environment all at once in a single click, so to speak. So this is my perspective on SysML and Unified Architecture Framework. For those of you who know, Unified Architecture Framework is the replacement for DODAP, and it turns out that there is a disconnect between these two paradigms. SysML does design and allows you to design a system, but it doesn't really do the other parts of architecture, doesn't easily do requirements, risk, schedule, business things. You can glue those on, but it's not really a natural part of it. And the Unified Architecture Framework is okay for doing the requirements, risk, schedule, cost, things like that, but it doesn't do design. So there is a disconnect between these two paradigms. And so we're going to talk about an alternative way of looking at a whole system view, which is going to take into consideration not only the design, but also the requirements, risk, schedule, cost, and so on and so forth. Here is a perspective of SysML. And I'm not saying there's anything wrong with SysML, because SysML can be used to do good systems engineering. It's not necessarily guaranteed that you're going to do good systems engineering, but you can do good systems engineering if you're a good systems engineer using SysML. The interesting thing about even the best SysML tool, arguably called Cameo, is that you can get a report in Cameo that will tell you all of the disconnects and all the things that you're doing wrong, and then you can ignore those things. You can say, well, yeah, I know all that, but I'm still going to ignore it. And that means that there's a potential disconnect in your systems engineering that can flow through the system. And in addition to that, you're also trying to connect up all of your models together. Now, it turns out that every time you're building a SysML model, you are building a custom implementation that is perfect for what your environment is. But the problem is that when you're building this thing, it's not necessarily talking to any other environment. So being the digital engineering lead on a couple of projects, I've got a bus that was created by one vendor and a payload that is built by another vendor, and they don't talk. You know, they live together because they, of course, were created in SysML, but they didn't think about, hey, well, let's make sure that we can talk at the end. And so now they're trying to figure out how they can glue themselves together based on the fact that they don't have a common information infrastructure. And this is what we're looking at, is the system of systems view, which means that I'm not just talking about something that's like a launch vehicle, but I'm talking about all of the other parts, like the ground station and the other satellites and the operator and all of these things. You have to glue those things together too, because they all have their particular way of connecting things up. And that, of course, would be enough of a problem if you were just looking at it from a system of systems point of view. But we're not. We're looking at it as an enterprise point of view, where we get to glue all the enterprises together. And that is a significant challenge with SysML. And it's not that you can't do it. It's just that there's a lot of money going on in that particular effort, based on that you're having to employ a bunch of people to not only connect up all these different models, but also verify and validate those models every time you make a change to a model. You have to make sure that all of your glue to all of your other models is continuing to work together. So I'm going to take you down a slightly different path. But before we do, I'm going to just talk to you about why we started down this digital engineering path. Well, we had this legacy system where we said, hey, I got a bunch of stakeholders, they need to be able to talk to each other. So I've got requirements and design and schedule and business and risk. And I want these guys all to talk to each other because they all have a part of the solution. And so we need to be able to get them to work together. And how did we do it in the old days? Well, we threw our documents over the wall. We said, hey, my requirements are in this document. I'm going to throw it over to the design guy. I hope he understands it. And he puts it together. And the design guy says, okay, now I'm going to try and put it into a schedule. And it goes on from there. And the challenge is, of course, that you are going to have a problem where you are going to be hoping that all of those pieces come together. So your stakeholders come together and they say, hey, what would happen if we worked together? I wonder what that would do. Hey, there's a thing called digital engineering. What about that? What is that going to do to our system? Well, let's take a look at it. If we brought all those things together, hey, maybe we would end up with a whole system view. And that is the promise of digital engineering. So that is what we're going to take a look at. And I'm going to suggest to you that a common information infrastructure is a start going down that path. So for all of those of you who are SysML aficionados, you will understand the idea of structure and behavior. And I'm going to start with that. I'm going to expand from there, but we're going to start with just two element types. in the common information infrastructure, it is called a component, is your structure, and your function is behavior. So what we want to know is we want to know how they connect. So I'm going to look at it as a components and functions are going to be buckets. These are going to be buckets that are going to be my element types, and the relations are going to be the strings between those. So I might say, well, what is the relationship between a component and a function? Well, a component performs a function. And so I can say that's pretty much common all the time. A component performs a function, but what does a function do to a component? Well, if I take it the other direction, I can say, hey, a function is also allocated to a component. So now we're talking about a complementary relationship between these two element types. So we are continuing to maintain an English language perspective. So the component performing the function and the function being allocated to the component. If I take this to the next step, I can say, well, hey, what about a requirement? What is the relationship with a requirement to these things? Well, I can say the requirement is the basis of a function, and a function is based on a requirement. In the same way, I can say that a requirement is will specify a component, and a component is specified by a requirement. But let's take it even one step further here, and let's look at it from the perspective of a risk. A risk is going to be something that can be caused by any of these things. Can be a component, a function, a requirement, or any of these things can be the source of a particular risk. But I want to take it even further with this subset of the common information infrastructure. And remember, I've just shown you 4 element types inside of a common information infrastructure, but I'm going to expand that out a little bit. There are about 50 of them. We won't go all the way into all of them, but we'll take a look at a few more later on. But right now, let's go to the next level, because let's put something in those buckets, because we know in an abstract form what these things actually mean, but I want to go to the next level. So I'm going to go to the component bucket, and I'm going to put an element, which is the launch vehicle. And I can say, hey, what does the launch vehicle do? Well, it performs the perform launch function. And the perform launch function is based on the launch requirement. And the launch requirement also specifies that you have to have a launch vehicle. But one step further, I can say, hey, now I've got a launch risk, where I can say, if the launch vehicle is not ready on time, then we will not be able to perform the launch, which is based on the launch requirement. So you can see now that we are interrelating all of these things in a semantically and syntactically correct fashion. And each of these element types and relations actually does have a semantic definition behind it. So a component is not just, oh, this is the word component. It actually has a specific definition as to what it means, and that is true of every element type that is in the common information infrastructure. So one more thing, let's consider not just a single element. Let's look at multiple elements. Let's say that I have a space vehicle, and I have the separate space vehicle behavior and the separate requirement. I could say that, hey, I have a separate requirement, but there is a risk. So I can say the space vehicle shall perform the separate space vehicle function. However, I can say that I have a separation risk that says if I have a separate space vehicle and if that function does not work. So if the separate space vehicle function does not work, then we will not be able to perform the space vehicle separating from the launch vehicle. And now you can see that we're not just talking about element types, we're talking about multiple element types within those particular buckets, and those buckets being connected by different strings in this particular case. So this is the idea behind the common information infrastructure. And we can extend that out so that we have more than just those four things: the component, the function, the requirement, and the risk. We can now talk about verification requirements and test activities and schedule events and work breakdown structures and things like that. So everything is interrelated in this particular manner within your common information infrastructure. So let's take a look really quick at standards management within digital engineering. Well, the first thing that I want to look at is, hey, I've got a standard element which is prescribed by a requirement. So my standard element might be something that is out of an AIAA standard or an IEEE or a TOR or one of the other mission assurance standards. But I also may want to have something which is what I would consider a standard tailoring, because I don't want to have a bunch of individual full up standards, one for each time somebody modifies the standard. Instead, I want to say this particular shall statement within this standard is going to be modified so that it will be specific to the particular contractor, vendor, whatever, so that they won't have to modify the entire standard. They just basically have a standard tailoring for that specific shall statement within the standard. So this is what it would look like. So if, say, I had a cybersecurity requirement, which is prescribed by a cybersecurity standard, it could be modified by the cybersecurity tailoring number 1 and the cybersecurity tailoring number 2. So one vendor might do it one way and a contractor might do it another way. And when you start doing that, then you can say, hey, I want to know how these particular standards are being modified over time by multiple contractors, so that I can now say, hey, this thing is being modified all the time by all of the vendors this particular way, so why don't we just update the standard? And that would be a fallout of this particular approach. So this is the aerospace specs and standards management model, which was the foundation behind this particular approach. And this is a look at the view of the thing in a particular web view. I'm going to see if I am lucky. I should be able to pull up a quick video if I'm lucky. Can we find it? Oh, here it is. The video, and we're going to take a look at modifying an entity. So I'm going to look at it, and you can see that I'm in the model and that I am able to modify the thing. There it goes. So we're running through it. And so we're modifying this thing, and this is all based on various views. If you looked at it, and if I stop this thing, I'll go back into it for a second. Then we will stop it. Go a little bit further here. Going into the model. Now we're getting ready to make the update. And so what you'll see is that we have a government tailoring, we have a contractor tailoring, we have an agreed upon tailoring, we have a final tailoring. So various things are going on here. Let's see if we get to that particular point. There we go. Okay. So you can see that you have the original, you have the government, you have the contractor, and the final. So the original is the unmodified version. The government is what the government is doing in response to the way that the contractor decided to modify it. And then the final is the agreement between the government and the contractor. So that is one particular view. The other thing that I wanted to show you is that we have the ability to output various information and put it into exported documents. So you'll see that it is coming out into documents there. Unfortunately, the guy I had cut this thing didn't give me a very long window to do it, but generally speaking, you can see that it shows, come on, come back, there we go, that you have exported your information, and it allows you to have everything from the short name to the purpose to the number and the description and so on. So that is looking at the tailoring, and let's go back here. We'll close this guy, hopefully. Let me go. There we go. Okay, there we go. All right, so that's managing tailorings in the standard. So what I want to point out to you is that you have your standards, and of course that includes your standard tailoring, but those are connected to your requirements, and your requirements are connected to your verification requirement, which is basically saying this is how I'm going to verify that the requirement is done, which is of course done using a test activity, also known as a verification activity. And going down a different path, we can say that, hey, the requirement also specifies various components which of course perform different functions. So that is looking at the interrelationships between the various things using the common information infrastructure. And this is showing how they are all connected up using parametrics. So in the Genesis MBSE approach, which is what the common information infrastructure sits in, it allows you to connect up your standards to your requirements, to your various other things, your verification requirements, your functions, your components, your program elements, which are your WBS things, your program activities, which are your schedule events, and all of those things, your risks and other things are all interrelated in the model. And I would like to point out that even though this is sitting in a tool called Genesis, the common information infrastructure is an open approach, an open standard. So you would not have to build this in Genesis. It's just that that's where it currently lives. It's not been implemented, as far as I know, anywhere else, but it could be. So my point is that the tool is irrelevant. It is more the approach that you have that is connecting all of these things from your standards to your requirements, to your functions and your components and your verification and everything in a single modeling solution. So this is my quick and dirty using the modeling and sim to impact system choice. So the first thing, of course, is that I want to have a digital twin, which is going to be intercepting the satellite from the ground, and I want to know if those two things are going to work. So I create a modeling and sim of those particular things, and I try and make them run, and of course they don't run successfully. But wait, there are two simulators with differing semantic definitions. So after I apply semantic fidelity, we have a satellite that gets destroyed by the interceptor. And so the question then would be, is this a new standard? I don't know, but this is something that we are building inside of the common information infrastructure. So I thought I'd at least demonstrate that we can do stuff. And what we do is we connect it up to a Python implementation outside. So we're basically going from a Python implementation of a modeling and simulation situation, and we are connecting it into the modeling environment so that we can demonstrate that things will or will not work in this particular environment. And so there we go. So this is, of course, connecting all of the things from the requirement, which goes to the various things, your position, functions, and your components, and connecting it to your risk. And then, of course, specifying the test activity through the verification requirement, and all of that being done within a program element, which is a work breakdown structure implementation. So that is connecting all of the things. And if you extended that, of course, you would have the standard, which is prescribed by the requirement. And so that brings us back around to why we are doing standards in this particular environment. So I am Dr. Digital, as you probably recognize by now, and I am in the house. So this is an opportunity for questions. Oh yes, I did want to show you one other thing before we go there, and that is, hopefully it'll come over. This is the aerospace specs and standards model. It has some 50 or so standards in it that it just so happened we broke them out into different shell statements. So we tried as much as possible to be atomic of these various things. And of course, the real authoritative source of truth of all of these standards is still the PDF that the standards are based on. But we did our best to take those standards and bring them out and atomize them where necessary if they weren't atomized in a particular model. So as I go through here, you can see that I have a number of different standard statements which actually capture not only the standard statement itself, but its shall statement within that. So that is the managing standards inside of a digital engineering environment. So back to here. That's it. So anyway, that's my perspective on managing standards in a digital engineering environment, and of course I am available for questions and comments. At this point, apparently, we're not up to the top of the hour, so we're still good.
Yeah, thank you, Daniel. I see we have one question in the audience, which is a question I had as well. So Andy asks about the CII. Is there a version accessible or available to other organizations?
Yes. So this is the common information infrastructure, which is based, as you probably might recognize based on my having said so, on Genesis. So Genesis is fully available. It's a commercial off-the-shelf tool, and if you wanted to look at the entire schema of Genesis, because that is where the tool is available, you can go into the schema mode here, which is of course just looking at the schema. You can modify the schema if you want to, but a lot of times you don't really need to. But on the other hand, this is a really good way of looking at the various parts of the thing. So if I wanted to, for example, to come down to something like, for example, a function, and I wanted to say, what is a function? Well, a function is a transformation that accepts one or more inputs and transforms them into outputs. And I can see here that I have all of my relations. So I know that a function is allocated to a component, it's augmented by an external file, it's based on a requirement, and so on and so forth. So this is all something that is available through the Genesis application. And as you probably have recognized by now, I'm not a Genesis salesman. I just work at aerospace, and I use Genesis because it has this really cool capability, but I also am not married to Genesis. If there were another solution that were better or more robust or had greater capabilities, I would not be married to, oh, I have to do it in Genesis, because Genesis is just a tool. But the common information infrastructure, which is the set of element types and relations that the thing is based upon, that is the important thing that I think can give us something where we can actually do digital engineering much more effectively. And it actually turns out to be a version of a semantic web. So do you think that answered the question, Andy?
Affirm. Thank you.
Awesome. So anyway, that's what I have. Any questions? I try and keep this thing fairly high level so it's fairly understandable.
Yep, we see a question or more of a comment from Deborah. She has a question for the first presentation, but we'll get to that in a second. But she says that she's happy to know Dr. Digital and can attest to the power of the framework that you talked about. So thank you, Deborah. And Andy says, also asks, is Genesis, is the tool conducive to containerization?
What is meant by containerization?
Andy, if you want to come off mute, feel free.
Yeah, so that's just the basic ability that several organizations are starting to build as they pull, referencing back to the prior discussion on ASOTs, is you have legacy data, the ability to containerize those for relative linking. I would assume Genesis is a fairly new product and it may have that inherently built into its capability.
Genesis is based on something called Core, and Genesis has been around for, I think, 15 years. Core was around for 15 or 20 years. Before that, it was based on something that came out of TRW. So the process upon which Genesis is based is 40 or 50 years old. So yeah, it probably is a little bit more robust than what you might think, because Genesis has been around in various forms for those 40 or 50 years. So containerization, I would assume, if you mean that can you contain different elements, can you bring those elements together in a container? I would assume so.
Yeah, it's basically for querying from other applications, that kind of thing, the ability to present class attributes and those kind of things that can be pulled from other apps as well.
Yeah,
I'm assuming it's probably pretty robust in that area.
yes, it absolutely is. In fact, there's a full-up API. They use the exact same API that they built the tool on to make it available to a RESTful interface, which basically means you can get to anything inside of Genesis if you want to. So yes, the answer is, yep, you can do that.
We have another question on can this ontology or the framework that you talked about, can it be opened or used in other platforms like Protege?
Through the API, through the RESTful interface, yeah. I know that it has an interface into MATLAB. It has an interface into let's see, I think it's called Model Center. So since it goes into Model Center, I would imagine you can get from Model Center into anything, and alternatively, you could do an API connectivity into the thing. The thing is based on C#, which is an open standard programming language.
Okay, any other questions for Daniel here or Dr. Digital?
I feel like Star-Lord. I was waiting for somebody to call me Dr. Digital so that I could actually open my present. So thanks for letting me open my present.
Of course. So it seems the chat has gone quiet. So with that, if I can take over the screen, we'll stick around a bit for probably until the 10 o'clock hour until people kind of drop out. But I do have some final kind of notes here, some housekeeping things. Okay, so yeah, thank you to both presenters. I think you guys presented some great information, and all of that will be accessible on the Systems Engineering Forum archive on the website that's shown there. So that will be made available shortly. They're not up right now, but soon they will be, in addition to the recording, which will take a bit more time. Give it a couple of weeks. In the next few weeks, the recording will be made available on the Aerospace Corporation's YouTube channel, in addition to all of the past events that we've had. All the materials available there and in the archive on the website. You'll also be receiving kind of a quick survey shortly after this event concludes. So we want to get some feedback, not only on what you thought of today, but perhaps of any new topic ideas that you might want to hear about. or any ideas of the like. But with that, I'd like to thank our audience members for being with us this entire fiscal year. This is the last event of the year. So I really want to, on behalf of myself and Alex Chang and Lori and everyone else who helped run these, and on behalf of the presenters as well, I want to thank you all for joining us, whether you joined for one event or for all 4 events. Thank you. It really means a lot, and we hope you picked up something useful from them. So as I mentioned, you can look at our past events on the SCF website and on YouTube. And stay tuned for events next year. And we'll be in touch via email, and on the website you'll see what we have in store for 2023. So with that, I'd like to thank you, and we wish everyone a wonderful day. And if anyone does have any last minute questions, we'll ask the speakers to stick around for the last few minutes. But otherwise, I think that's it. Yeah, I guess if there's nothing else, yeah, Lori, you can go ahead and stop the recording, and we can wrap up for the day and close the meeting in a couple of minutes.